share the screen.
It's not
So,
sure.
automatically.
Yeah. It should automatically. It's not sure.
It says 1 of 2, so let's see what second is. It says no signal.
It's not reading.
Start on
The grey one.
Which one?
I think.
This? No. This is for USB.
No, there is another one, the grey one.
This is the one.
No, the grey one, another.
Oh, okay.
I don't know.
Is it?
Similar to this one, but it's HDMI.
This is the HDMI. Yeah.
No, I know. Yes, yes.
Oh.
This or this?
But it's not.
Oh, this one connects, this connects.
Disconnect.
I think here. Yes, HDMI. Here, right? Yeah.
Let's try this. Not showing anything.
That's only a problem. Let me then check. Maybe.
Okay.
So extended, okay. That's good.
You want it extended or?
Yeah, it's okay. Extended, yeah. Oh.
Second screen only. You can. So,
Okay.
just put it in so.
Ora.
Everything is open. So we manage this. Okay. Oh, it's in.
Is that?
So, okay, let's start with this. My name is Srdan. I'm coordinating system study activities on HVDC project. So, I don't know, but you're recently started your engineering work or just?
Yes,
Yes. So you're so you're just
Freshly
freshly graduates.
Yes.
Okay. Well, I was thinking how to start because the studies are very complex thing and we have very short time for this. And I was thinking how to give you a picture what is the role of system studies in this project and in any other. But did you, during your study education period, did you have a chance to see any software for system simulations, electricity floors?
ETAB, you mean?
ETAP, yes, like ETAP, yeah.
Power World, I think.
Yeah, but you are familiar what the software supposed to
Yes.
do? Okay.
Where is it?
We work with education.
You work with
like
because
MATLAB or something like this.
Okay, MATLAB is
Education purposes.
Yeah. Okay, so we have a rough picture. So basically, how to for HVDC and for this all new bigger renewables which are now trending in building of in developing the transmission system, there is a set of study which is much more complex than studies which are done before, where you have only conventional generation, like big generator, with mechanical things, and this kind of stuff. In renewables, including our project HVDC, you have power electronics, and there is no mechanical parts. And basic idea is what utility or Saudi Electric or any other company would like to see in their network, that this HVDC sources of generation, the target is to get output of these sources similar to conventional generators in behaving in the network. So that means how normal generator is behaving in case of short circuit and this all other disturbances in the network. There is changing behavior in terms of increasing frequency, all this kind of stuff. Is a complex thing. Similar, the final target is to have similar behavior of HVDC,
The
electronics.
natural energy of the
Including inertia, including fault current contribution, including everything. So basically, I was, instead of just listing the study, which could be very confusing, and I was thinking really how to do this. On which side? Okay. I end up only with this, let's say, one single slide. There is some description of studies here, but basically I think I will go through this. It looks like very confusing and complex, but we need to start from somewhere. So basically, before we start with this slide, and we will go through it and I will try to explain all steps. I will just give you one more general picture of studies, what we need them, why we need these studies, and what is the role in overall utility development. Then we'll be focused. After that, we will be focused on our HVDC project. So basically, when you join the project like this, that means contract is signed, and all those contract activities started in terms of procurement, equipment, building everything. But before this contract is signed, there is few years back or even more, there are a lot of studies that needs to be performed until you get green light from technical point of view. Yes, you can build, for example, your HVDC line here. So all this kind, software like ETAP, but it's not ETAP, it's PSSC used in transmission company. ETAP is more related to industrial network in oil and gas sector, where you have a couple of internal generation and connection to utility maybe. But on a state level, PSSC software is preferred here. There is another one, it's Dixine software as well, used mostly in Europe, but depends from utility to utility which software is preferred, let's say. So as I mentioned before, that there is just idea. Some say, okay, we would like, because we have central, we have, for example, I just took West, for example, we would like to have interconnection between these two centers because they are like independent, and we want to make network more stronger in connection and exchange energy and so on. First comes like an idea, like feasibility study. Then people in utility, in SEC, they have developed in PSSC, similar like ETAP, they have developed complete network on the state level, on Saudi Electric. Here, for example, on 380 kilovolt level, with all generators connected, with all devices connected, with all loads connected, and this kind of stuff. So then they get tasked to run set of studies to see whether the network will behave stable or not, to estimate load flow, short circuit, transient stability. So they will simulate what if fault happens here, what if fault happens there, what if my generator trips, whether the system will remain stable or I will have blackout, all this kind of huge number of studies and cases. And then once they finish these studies, they conclude, okay, when they did these studies, they took, like, there is generic model of HVDC, so very, very simplified one, just to check all this. And this will say the study will say, okay, it is feasible to build your HVDC here, go ahead with contract, these parameters needs to be checked during contract stage and so on. And yes, now project started. We are in the project, for example. So now contractor in contract documents, contractor have description of studies that needs to be performed. So now I'm gonna talk about these studies and how supposed to be performed and finalized, because it's not finalized yet. It's very critical, and it's really we are struggling a bit to convince contractor to do all studies. We have one more thing, small details before we start diving in this. Since this is new technology in the network, the list of studies and requirement from utility is I would say still a live thing. It's not finalized, not only in Saudi. Okay, for the contract, when you sign the contract, you have some studies finalized and how to do it. But there is no overall, let's say, globally accepted methodology how to do. There are depends from utility to utility. You know?
Is it because new? Is it because the technology?
It is because it's new technology. So renewable started some time ago, and basically in Europe, you know, and in initial stage you had a lot of conventional generation on coal, on gas, on turbines, and nuclear, all this kind of hydropower. And those are, you know, well known for system study analysis, how to model.
They already unified the standards for those things.
Yeah, but it's already quite defined standard. So renewable started some years ago, and you know, when you have a lot of conventional generator and here and there renewable, you know, then you know these conventional could tackle it all problems that could come from renewables. But in recent years, a number of renewables are increasing, and these conventional are decreasing, or you know, the ratio between them is changed, and utilities started experiencing some issues, you know. So now they have become more rigor. They set more rigor rules to the contractors and to manufacturers, how to build their HVDC, but also how to build the battery storage system, PV plants, wind farms, and this kind of stuff. So you may find, for example, a contractor who build HVDC somewhere where this is first HVDC, and it is, you know, a lot of commercial can deal with this easily, you know, when they bring their experience to, for example, in Saudi, where you have a lot of renewables, then you know the rules are different. Utility asks different studies, and this is new for contractors. So some are ready for this and accepting this and trying to do the best. Others trying to avoid because this is additional cost for them. They in their head, when they are bidding for the project, they had, okay, we did it there, similar thing we will do here, but it's not easy. And why I'm relating to study, you will see from this like flow, it is very important, you know, to follow these studies and to make sure that the HVDC, but also for renewables, will behave safely in the network, will not cause issue in this kind of stuff.
So at the start, let's say they knew that the planning department at SIC should do the first feasibility study on whether this link is possible or not.
Yeah.
That's initiative, like initial studies on.
Yes. That's basically initial stuff. Planning department. The word says planning, so you're doing plans. So you can do, usually plan department is on 5 years horizon, 10,
Yes.
15, 20, 25. If the country has a vision, you know, I remember when only conventional generators were there, you were doing like 20 years ahead plan. In this plan, you will take into consideration, for example, a number of people will increase. So that means now, on statistic level, per capita, per one person, how much energy the country is spending. So we'll say, okay, I'm guessing now from 10 million we will have maybe 11 million in 20 years people. So that means increase of energy consumption. That means each household is getting new devices. So the one house is putting more electrical devices, so that will also increase demand of energy. And so
The
this
load
is
profile changes.
sorry.
The load profile changes.
Yeah, load profile changes. Then you will say, okay, since we will have increasing population on state level, I want to develop this area, so we'll try to develop some industry there. People will move there. So then you have to plan. I'm talking about 20-year horizon. Then you have to plan. Okay, what kind of industry I want to have this. If it's just like having big halls with storage facility, you will just have light in air conditioning. But if you have smelter aluminum, or which is huge, so you have to make arrangement. This is planned. This is the basis. Then based on that, people from generation said, okay, now we have 10 gigawatts, for example, on state level spending of generation. We will need 12 in 10 years, so that means where to put this generation, close to, all this kind of stuff. Then study will be done, developed. We will have very simplified studies, and this 510, this is the so-called master plan, or I don't know, depends from utility to utility. This study, when you develop it, let's say, it's not just to do it and put it in on shelf and forget about this. With this study, you have the base to go to the SEC, for example, Saudi Electricity, have the base to say, okay, to government or to whoever, to ministry, say, okay, within 3 years we should build new overhead line based on the study. Within 5 years we need to build new power plant based on. Within 3-4 years we need to build HVDC, for example, because this plan on 20 years is not fixed. It could be adjusted every couple of years. So at some point, Saudi most probably had this kind of plan. Then at some point, government decided, okay, we want to put more green energy, maybe to be greener in the world, So they adjusted,
Yes, not only this, because there will be a new technologies. Let's say, for example, 20 years back, there is the advance of AI is not like today.
Yeah.
Today require more power because of the data center.
Yeah. Data center is huge consumer of electricity. So this is how the things are working, And this is done by planning department. And now, for example, in our HVDC, we are executing the project, And once the project is finished, we will have developed model, again software model for PSSC, because Saudi has using this PSSC software, which will Saudi Electricity put this model and incorporate in their overall model and run studies for next projects, and this model will behave, one day simulations.
I met somebody there in the planning, and I saw them working on this. I think this PSCAD as well.
Yeah, in PSCAD.
They showed me like different buses. They showed me different buses in the system. I think they have like Riyadh network alone, Saudi Arabia in general.
Yeah.
And they, as you said, they have done like studies. If we connect this substation to this substation and perform fault analysis, what could happen? Is the system like will the transient the system.
Yeah, transient stability also.
And as you said, the models, as you said, if the project finishes, they will receive like a file or a Python file, then include the model inside the overall,
Yeah,
and
they call
continue
it,
on with the other project.
yeah, they call it user-defined model, you know, so that means model developed by contractor.
Yes, yes.
There are some, when you have commercial generation, just to add to this, you have typical models because there are typical turbines which are mechanically typically built, so you just need to change parameters, you know, like for transformers, so it was easier to develop this model. But in this case, you know, it's really related to manufacture, how manufacturer do in software, and you want to have the same behavior of real device to be reflected in your model. So basically, imagine this is, I just presented here like part of the network where you have normal generation PV plant, battery storage system, and there is a lot of huge network for west, few network for central, and you have like planned HVDC here. So PSSC is easily dealing with simulations in this way, you know, when you have complete network. But before PSSC, which is similar to ETAP, if you saw it, we need to, and this is so-called RMS type of network, frequency domain. There is time domain, which is done in PSCAD. So modeling network element like cable or transformer in PSCAD is much more complex, much more details are required, and you cannot model complete Saudi electricity network in it, you know. People are usually focused only, if we are focused here on our HVDC, you see it's dashed like planned, I put it here, and this is west part. And
They
this is,
sectionalize the system. They sectionalize the system.
Yes.
The
Yeah.
right sections.
yeah, they literally, they will be focused on the maybe first bus bar here, and maybe a couple of line around, maybe one or two, three more bus bars, and on the new device, whatever is new device, transformer, battery storage, in our case is HVDC, and the same thing will be done on this side. So, and how to do this? They will develop network equivalent of west on this side and on central on this side, and then it will be, here you will have HVDC model. So what means network equivalent? For example, if it's network equivalent connected to this bus bar and our HVDC line, they will reduce network size. You will not see any generator here, anything here. This network equivalent, if you simulate short circuit with complete network here, and short circuit in complete network here, you will get the same value. You know. So this equivalent, there are parameters here, will actually electrically represent all network of central, here all network of west. So you can simulate short circuit, you can simulate load flow, you can simulate dynamics also. So that means all generators here in these parameters, dynamic generator parameters will be encaptured, you know, and you know.
So they simplify the whole of the city
Yeah.
into this bulk point.
Yeah. So we are not, for example, we want to focus only on our HVDC here, on our project. So they will squeeze this. There is, even software can do it automatically, no, but you will have here only list of parameters, here list of parameters, and you will do, I mean, it's usually done by SEC. They will do benchmarking, so they will simulate here, like, you know, short circuit, and they will watch how the system will behave. So they will put one short circuit curve receipt here, short circuit curve receipt, you know, here, and then you will compare it and should match, should be very close, very similar. Dynamic simulations also, and then once it's everything done, then you said, okay, I'm happy with results. So this network equivalent is representing my west, this network my central part. So now I can start studying of HVDC. So this is like first step in developing this network equivalent as it should be. So now we have a couple of steps which will run in parallel, but that's let's say the first step. So now you could say we have so it's when you start like overall network, then system studies will be done. It will be run to check again how the network will behave if you put hypothetically the HVDC. Then you develop network equivalent here in the PSSC, and in the same time, manufacturer already developed their HVDC system converter station, and as for any manufacturing equipment, even like PC or whatever, you have manual. And they will also deliver this manual and start developing the model of this HVDC. So now they need to start developing this one as well. So for example, here you have HVDC model and model quality test. So they will develop model, and then you will have manual, and they will show how the system should behave and curves and everything. And they will also develop model in PSSC and run simulations and compare. And the curves and everything should be matched. Saudi Electricity, in order to check model development behavior, they have like a list. There is procedure, and they give contractors, say, look, simulate this, simulate that. After fault, your system should be stable. The curve should not go more than 10%, 5% of set value. There is description.
Standard.
Yes, standard. So in some cases, for example, it might happen that contractor will not see this part when they're reading, where they're bidding, or they see it but like ignoring, or they say, okay, we want to win project, we may do it, but we never did it. Let's say, it's not us. Other utility didn't ask this, so it's live project is full of everything. But I will just talk to the big picture of this. So you develop model in HVDC as well, and then you have here model quality and the benchmarking between this PSSC RMS study and PSCAD study. So in parallel, both models will be developed, and both needs to match.
But PSC is done by utility?
Yes, PSCC is done by utility, but PSCAD is done by manufacturer, let's say.
Manufacturer or the contractor?
Contractor. Oh, yeah, we are calling contractor, but in our case, we have two HVDC line, but contractor is they're not manufacturing it. They subcontracted the HVDC converter station.
You mean state grid? You mean state grid?
Yeah, the state grid is contractor.
Yes.
But for example, you have their contractor, then they are buying transformer from Hitachi. But this converter station they purchased from, there is NR and XJ, two manufacturers in China.
Yeah, China.
So for one link is NR, I don't know what abbreviation stand for, and XJ for another. But this manufacturer is supposed to be, because the one who is making something, he should provide also.
So the comparison you mean model quality test will be between the one done by in the PSC and the PSCAD for the manufacturer, right? From utility and the manufacturer.
Yeah. Well, they need to develop it in both and compare both should match. Or you know. So to do this, yeah, I highlighted here this step. So first, there is also this description. I will just say first, the studies are done in a very simple way. Then, I mean, simple workflow short circuit. Then they will do multi-dynamic, but both should match results. When I simulate short circuit and keep it 300 milliseconds, and then it's cleared by fault and voltages, you know, system should remain stable. So it will go like down, then like something like this, you know. And these curves, I may even dig out from some studies. They're putting in the same diagram, different color, where they say this is PSSC, this is PSCAD, and you can compare, you know, momentum and this.
What's the difference like, between using the PSCAD and the PSSC?
Yeah, okay, that's RMS is, you know, for frequency domain.
Okay.
Yeah, PSCAD is time domain. PSCAD, I have just it here. So information from PSSC, which side? So this is one kind of network equivalent I was mentioning here. This is just simple. But here is, you know, yeah, there are some information, rating, for sure circuit parameters. So this is now completely different. Basically, you know, so this information you can simulate short circuit, low flow, and you will see that, and you can do it for big, huge network. Time in PSCAD, it's time domain. It's much more detailed, and it will actually reflect much more precisely what will really happen in the network. All these sinus curves of, you know, you will see literally the same time, you know, any disturbance, and it is more precise. And, you know, here you can see basic in frequency domain, which is very important. Again, here you can see the same values which are measured on the CTs and UTs in the network, and which are shown in National Control Center. I don't know if you had a chance to visit this. It is huge. Should be, I never visited it, but usually National Control Center has a huge single line diagram with all the flow, generation, injection, how much power, you know, those ways. But here is PSCAD is much more time demanding to model, to be, you know.
Other than the type of domain, PSSC is more general for large systems.
Yeah.
And PSCAD for
PSCAD is more precise, but again, what you can do in PSSC, also you can do in PSCAD for this small network. You know. So what you simulate on PSSC, you simulate short circuit, you simulate here, and short circuit current should match. You know. Dynamic model, you simulate fault, clear the fault, and watch frequency, voltage, you know, and you will get some curves. The same in PSCAD. So the target, these two must match. Why is that important? Once you reach this point, that will make sure that here is your network equivalent, also benchmarking, and PSCAD goes in parallel. Once it's the results are matching, that means your PSCAD model is correctly representing PSSC model, which is our start point, and which is, you know, this is our utility start point, and this model is, how to say, representing real network in the best possible way in simulations. So if you simulate load flow and open breakers somewhere, you will see load flow how that goes. If you do it in reality, you will see it's not the same in terms of amps, but it's very close to these tolerances.
So if they match, like, this is a sign that we have like done a good model, and it represents our like HVDC system, for example, here.
Yeah.
Correct.
Yeah.
The parameters are right, and
Yeah,
we
yeah.
expect if anything happens to perform as we simulated here.
Yes,
these models.
yes, yes, that's the target. So that means once benchmarking is approved and the model is approved, you will get PSCAD model developed. So that means exactly what you said. The HVDC model behave as stated in manual, and this equivalent are behaving the same way as PSSE, so that means the same way in singularity. I could not say, I'm using it the same way. It's, in reality, you always there is difference, but this is the best possible simulation of reality. So let's consider this. Don't say, okay, what is there? It's you have to be aware of, even in this model, some mistakes might happen. But this is the best way. This is the way how the project is going. The ultimate target with all these exercises is at the end of the project, you're actually minimizing. It will not eliminate any problems in HVDC, but you're minimizing the problems and surprises that could happen in operation later after 1 or 2 years. Fault happen and your HVDC behave as should not. So, but this always could happen. This is how to control. Without these steps, you're doing, and you're just install something on site and put it, with some tests which are not according to this. The system will work, but you have no control of whether it will trip for simple thing or no reason, or So this way, you're controlling this in best possible way. This is globally accepted methodology how to do it.
The differences between these models in terms of results that I get.
Mm-hmm.
Like when is it I say this is acceptable and I can go on. I can verify that these models are okay and we can go on.
Yeah,
There are knowledge,
yeah. For each of these steps, especially here benchmarking, we are. By the way, for the project, we are here right now for last I don't know how many months. This should be finished a long time ago. But the contractor is. We have issues with they have different approach. They have different network, and they did not adopt. I mean, I'm going now out of this scope. From contractor point of view, we don't know why I mentioned you have contractor and you have manufacturer. Yeah. During bidding stage, if I'm contractor send I said okay, Saudi want to build HVDC, this is bidding document, can you supply this? Then they will say yes, and then they will negotiate. So maybe manufacturer told, we don't know, we don't care to be honest, but I was working on both sides of my career, so this is why I'm telling you, sometimes it looks good. Maybe they did not agree, the contractor asked manufacturer, okay, no need for this study, we will go without study, reduce price for us, because
yes.
You get the point, you don't know really. Or maybe they overlooked, or intentionally or not intentionally, you will never know. So you have to stick with your BTS contract requirements, and insist this, and then.
Like they are hoping that we are elected or what.
Well, I don't know. It's I'm now
Certain the BTS, so it should be applied.
Yeah, everything should be
I
applied.
don't see an escape for them.
Yeah, should be. We are here to tell this, but at some point, well, those are also tactics of contractor. They will push you in the corner, and according to plan, for example, you're supposed to energize this. I'm guessing now in October this year. And yes, from a technical point of view, and we're arguing, trying to convince them, but at some point of view, someone who made decision this is supposed to be built at that time, also may need to be involved, and they need to agree or something. From technical point of view, we just can say, okay, this is a BTS, they did not deliver, they cannot deliver, these are consequences, these are risks, and this kind of stuff. They will ask, what you did to convince them, then all these letters, emails, you know, at that moment become important.
Because the ministry, they don't care about these details.
Yeah.
They want, just, as you said, the implementation date is very important for them.
Yeah.
Because we are expecting this project to finish at this time, so they're expected to finish at this time. Yes. So it's our responsibility as I think as Srdan Energy and the other stakeholders to like figure it out between us and try to finish as soon as possible with the best practices. Let's say.
They will try everything, you know. They already tried in this project, you know, the sense study which could not be accepted. I will use nice words, which will not be accepted really for technical persons. And the scientists said, look, if you don't approve this, then you know, if shipment will be late, then project schedule will be under question. So they put pressure on, you know, it is common game you know, so that depends from from country to country, from contractor to contractor, but there are so you have to be aware of this and not accept this kind of pressure. You should share information. Managers.
Quality is important as well.
Sorry?
Quality.
Quality, yeah. Quality, of course. Reporting also is important. Because all this, what they do, they develop models, send us the model to check, and sharing it with specialists in Canada and also sending reports. So also reporting is important in studies because you can do very good job, but if you are not reporting it correctly, you know, it's you know, like in study, you know, you can work in exam, for example, a lot, and you know everything, but if you are not presenting your knowledge to the professor, you will fail. You know, it's not measured, what you know. So anyhow, also reporting.
So they'll send you, let's say, the entire model, the HVDC and the two equivalent benchmarks, right?
Yeah. They will send, for example, for benchmarking, we already receiving but they will send in ESSC this equivalent, and the report will be focused on this red highlighted atom equivalents. And similar for here for HVDC model. So you see one exercise is to make sure that equivalents are correct, another is to make model is correctly modeled, and they will send reports and compare results and say, okay, for I don't know, transit stability, in case of fault here, we will receive in PSSC this curve.
So you guys at Atkins will also like resimulate this, or just you will review the results?
Well, what I found in Atkins is asking in their resimulate. They're doing what they state. They will just rerun and double check. I mean, we will. I'm talking about specialists who are working on this software, and they will rerun it. And again, double check, and in some cases we receive a report, we have issue somewhere, then we'll, specialist also open the software and check. If he's run many studies, he have idea what the problem could be, and he, for example, find, okay, your model, you made mistake in this parameter, correctly, then run study.
Then return it back to contractor to modify.
Yeah. So as a consultant, yeah, we're giving advices to CT, trying to to get model.
And this takes a lot of time, right?
Take a lot of time, and yeah, the quality is very important. If you get very bad quality, you cannot give him advice. If you, what we also see in this project, we give them instruction, look, do this, make this, do that, do this, stepwise, which is not something invented by us. It's based on my experience. I have it in Europe, based on engineers who has experience in Canada, in Australia. So it's globally, accepted. We are saying, for example, in this project, do it that way. That's the best way to do it. We said, oh no, we consider this as a double work. We will do it at once. And they spend a lot of time, run study, and come back to us and say, okay, we have issue here. So then again, to to figure out where's the issue, you should go back and, you know,
Follow this.
and then nothing happened, and you know, we're sending letters, you know. So it is really complex in this project. So, but again, I will keep explaining here how it should be done, you know. So what is our
Ideal.
what is our target actually. So once the we reach this point, that's PSCAD in these system studies. PSCAD is model is developed and these are approved. Then there is a set of PSCAD system studies in which the behavior of HVDC network will be simulated. So that means you have bipolar HVDC. So you say, what in case of fault on one pole, what we have? There is so-called test matrix. So what exactly we want to simulate? And
Like possibilities.
sorry?
Possibilities that what faults can occur here, you know.
Scenarios.
Scenarios, yeah. Various scenarios. Yeah, this, by the way, you mentioned scenario, you remind me. These equivalents are developed not for only one case. It's developed scenario for many scenarios. When you have maximum load, all generator connected, maximum load on your state level, then interload which is lowest, and during which period conversion generator are doing refurbishment work. So, for example, if you have 50 generator connected maximum during low generation, low power demand, you will have maybe, I'm guessing, 35, 40 or something, and utility in that period use this opportunity to do maintenance work for generators, which has to be done periodically. So they disconnect to do maintenance for, you know, some period, and also maintenance for overhead line or transformer. You know, when you have no big load, then you can disconnect some equipment, selected one. You know. So all these kind of things are.
So even the benchmarking will be done also using multiple scenarios, like only one scenario.
The scenarios are defined somewhere in the beginning here during these studies.
Okay.
Here, they'll say, okay, these scenarios are most critical for our network. So you use extreme cases, maximum, minimum, and to model, and you expect for, if you simulate fault in these, so you expect when fault happens somewhere in between, because then the system will behave well, if behave well in these extreme cases. So now you are doing this set of PSCAD dynamic performance study. It's called so, where you have this matrix. Matrix is also discussed somewhere in the beginning, and you will simulate faults, fault clearances. What if fault happened here and the system block here? You know how whether the converter will behave as SPTS requirement, as grid code requirement. So all these small parameters and curves and tolerances are either contained in grid code or in PTS.
What does the EMT stands for?
Sorry?
EMT.
I have to double check. We can Google out. But you know, it's time domain. Time domain studies.
But what did you say about the program used for simulation? That is the PSC? PSC for sure.
Yes. You see the blue is PSSC. And here is, you know, you start mix of PSSC and PSCAD. Here is PSCAD.
What is the main difference between them?
Sorry?
What is the main difference between the PSCAD and the PSC?
Well, in details, which you PSCAD can simulate and give you much more details. It can give you curves, literally, which you can on oscilloscope see on networks, something like this. And here you cannot see in such level, in such
Frequency.
level. So here, it's we'll come to this point why it is important. You know, it's when you simulate. So now, when you simulate this, in this case, in PSCAT studies, you will here we still have this model developed. You know, you will have much better picture how HVDC system will behave in the report, and you will get report, and that report is important, and that report results needs to be in line with PTS requirement and report. So, as you see life cycle, we have large network, then we made equivalent, then we RMS, then we made PSCAD based on PSC, this equivalent and HVDC. Then we have PSCAD model developed.
Electromagnetic transits.
Yeah, electromagnetic transits. Yeah.
So why is it in green?
Just to make difference for you, I just put green to know that at this moment we are not comparing anything between PSSC. We finished the PSSC. We, let's say, correctly reflected all PSSC behavior which we could reflect in this. So that's the case. And we will get report out of this. So next, there is RTDS. Again, the real-time domain. Again, another software, and which is the same as PSCAD, with one difference. You will have equivalent test also.
Why do we need RTDS?
Now, next step, I will explain here. So RTDS is something that everything is on PC on computer simulations. So RTDS is devices, and it's a bit complex to explain, but again, it is computers, but they could, whatever you simulate, like in PSCAD, and you get output of current or voltage or something, you can create output of this behavior, and inject real voltage, real current, real. So why is this important? So imagine RTDS used in laboratory. There is in Daman, there is institute for, I can't remember exactly the name, so you have like computers for this equivalent, and you want to make this equivalent is the same in this PSCAD. It's the same type of software, so it will not be a big issue to develop, but again, you need to do this test and exercise. And again, since you follow this step, this RTDS equivalent will behave in the same way like this PSC. When you simulate a fault, again, everything should match. So that means here, for example, in the laboratory, you have one computer where you have RTDS model, and another computer, and so on, because they're interface devices. And now, once you finish that one, you will start working on RTDS here, hardware in loop tests. So between these two equivalents, manufacturer will bring the real cubicles, which will be installed in the real on site, put one which are connected, and you will start simulating faults. So now whatever you simulate, like a short circuit, by these devices will inject in your real cubicles.
From manufacturing.
Yeah, all these voltages, curves, fault simulation, and you will monitor how your cubicles will react. So with this RTDS, we will simulate the solid electricity network. And you say, if I have fault here, what will happen? And you see how these electronics will control HVDC. Will behave better, what it will be done. So you will simulate all possible cases you will want. So this is give you confidence then once this test is finished. And this RTDS, here you look test, this is so-called FST. Factory FST, factory system test or factory acceptance test for HVDC factory system test. And it is critical now, it's ongoing and most probably will not be successful. So maybe they have to repeat it. It's already postponed from December, so it's trying to
But this cubicle,
yeah,
represent what exactly? Represent the HVDC?
Yeah, percentage, it is HVDC. Here you will, how about this power electronics, you have firing angles, so you can increase voltage, reduce voltage, this technology.
But they will be physically there?
Yeah, it will be physical. So you're testing physical, yeah, with this RTDS model finally equivalent. This represents Saudi network in terms of short circuits, voltage behavior, dynamic performance. So you simulate volt, and for example, it will be the same behavior. They will simulate and inject these signals to real network, because same signals will be seen by these devices when we store it on site, because they will from CTs with this correct information.
Yeah,
So it's not only simulation, it's really injecting those.
Signals from CTs. It will not inject kiloamps,
Okay.
something, but it is reduced to CTs, so maybe secondary injection. To be honest, even myself, I was not in this.
Yeah,
I know more in theory, but it's not so. But it is. I will have to be this tests.
These are done in the factory, so the manufacturing.
This is done. This will be done in factory.
For the equipment that are used on the
The
line.
equipment that will be used on the site, that will be installed on the site. And the same way you can track even the relays. Now I'm going out a bit from this project. Normal relay protection way, in the same way, there's a much smaller scale. You can test it here with relays, on relay, vertical relays.
So those tests are done before installing those equipment on the sites.
Yes, it is before it is even installed on the site. So this is what I call factory acceptance test, and it is very important because there is difference when you compare this testing with, for example, relay, relay protection. Even if you test it on factory relay, when you bring it to the site, you have digital numbers, you can tune it, check it, change it, you can play with it. With HVDC, you cannot do this. What is tested, fixed, you bring it, you have this option. You have option to tune things. I will tell you how you can tune and change things. But it's, for the project, it's, you've done test is done, you cannot test again.
So there will be commissioning for.
It will be commissioning. Then commissioning will be. It's not like offline commissioning like for relay. It has to be connected to the network and see it here. So while you're doing actually all this kind of test, once it's connected to the network, you expect minimum possible, let's say, issues. And to do a commission test, to connect this, you have to agree with central and south. So we say, okay, we are planning tomorrow test transfer maximum power from south to east. It's complicated to do the commission. It has to be done online.
There's also, if this was not done correctly, maybe future projects will also affect it. Maybe.
Yeah, future project. Okay, we also that's good. So, but also your project, then you may start doing commissioning based on some issues. And you don't know how to explain it. Or you can, or maybe people, they know they will do the water project, but they will come and maybe tune it. And imagine that, okay, you are tuned now. Imagine, for example, that moment is during summer peak time. And you tune it in summer. But winter situation in network is changed, dynamic is different. You know, not all generators are connected, load is different. And again, HVDC was the problem. so this is why all this study, all these cases, starting from cases need to be done. So you want to make sure all you know what your network weaknesses are tested. You know, and you say, okay, now I'm confident that even if something happens, it will be, you know, we did our best to avoid this. So if you don't, then it's
But so it's not in terms of commissioning, there will be different from AC regular AC stations, because here it will be mostly done at the factory. That's what you mean by that?
Yeah. So for relay, we will do commission course. We will do for relay protection. Normal, you will do, for example, testing on factory and to confirm, you know, relay operate with these values. You know, so you said, okay, class, good. Send it to site. On site, you will inject real settings, and you will again do commissioning, see so it's connected. You know, relay is different, but in this case, commission will be almost daily connect wiring, and when you want to confirm if this works, it has to be connected to network. So that's the only thing, you know. So now you're coming to this point when you connect it to network and you did this equivalent and you did this kind of test. This should actually in idle situation, commission should go smoothly. You should not have a big issue because you test all possible things. But what I mentioned in the beginning, you know, is before on this kind of test, when you get very few HVDC network and renewables and this kind of stuff, it was easily a big issue. But now you have many other devices, and this make network a weaker in terms of short circuit current contribution, because the renewables are not contributing as normal generation, so this make your system more unstable. Let's say. When you have a lot of standard generation, you know, for short circuit, it will recover quickly and smoothly. You know. But when you reduce generator, increase this, the change will be more. Say it will not recover easily, so you have to.
You mean the short circuit impedance of this?
Yeah, short circuit, generally short circuit levels for this short circuit ratio, which compare rating power of HVDC or battery storage system, they call it IBR, inverter-based resource something like this.
This is a very important topic, the short circuit level in the whole grid.
Yeah, you see that before you had problem with high short circuit levels when you have conventional generation, you know, it's require additional investment or so. But now, since the renewables are increasing in number and this short circuit level is decreasing, then you get this ratio which is not in favor of this. So you will have your network will not be so stable in frequency. So basically, in this Hill recovery loop testing, you test the cubicles to the site, and you will send it to the site. In this project, it is required from contractor also to deliver a replica of these cubicles. So the same set of cubicles which control and protection, not all cubicles you can see, but only control and protection of converter station will be delivered in the map. and they will use this is the best network equivalents also, you know. They will use it for simulations in future.
We are currently in benchmarking stage, right?
Yeah, we are currently benchmarking stage. So this replica, it will be used in the future. So what that means, after 5-10 years, you will have more renewables. So that means your network will be changed, your network equivalent will be changed all the way down here. And people in this laboratory will periodically run studies on these replicas. They say, okay, now network is changed on that level, that operation of our HVDC, because we have replica of cubicles, the same what is there, needs to be tuned. Some settings need to be tuned to move from this number to this number, because they will do testing. And it will be, well, I think so, I never did before this, but I think once they tune something and they're confident, then it will be literally now it's software upload to the computers inside and the system should change behavior. And the idea target, I think, of the institute is not to have the same set of replicas. This for our project, but for all future is converter-based resources, that is PVs, all this kind of stuff. So then they will be able to do simulations and to tune this to change something entirely. So this is why, and finally, once this test is done, and that means in solar electricity they will have this RTDS model in the laboratory. They will have, before they do any test in future in RTDS, they will do it in PSCAD model, which again is equivalent, and this model are aligned the same, you know, practically, and also the same will be reflected here. So any change in tuning in the real cubicles will check and reflect in the system. And this is how you could monitor what's going on. So it started with studies, but you know, and you finally end up with you know installation of cubicles, and you know, so now your network, you have HVDC, your network one project is finished, and they will already use this model, you know, to run studies for some future projects, you know, and then they will say if the HVDC model is modeled correctly, they will say to next future project of HVDC or whatever, they will say, okay, you can build this, or the system is weak there, you should build one new cable line, you know, reinforce your network.
Is the testing or in general the what is it called? RTDS?
RTDS.
This is done because this is new projects. Those are new projects, right? So let's say for the future, if we have any new projects, they will do the commissioning as usual in old AC stations. Or it's this procedure has to be. What's the purpose now of doing this, not regular or usual commissioning in that regard?
This is before, say.
Yeah, but before.
Why is it done that way? That's what I mean.
Well, before you could model everything in PSSC, it will be enough. You can precisely model behavior of generators, because it is. Generator, you know, generators, you have a couple of turbines, typical type of turbines, this inertia, everything, and mathematical models are well developed, you know, you can,
parameters you can
yeah, or it's not so big issue for manufacturers for them to develop and hand over to the system. But here is, and it's mechanical, you know, it's fixed. There is no, maybe after some years this mechanical wearing of, you know, will change a bit behavior, but it's the same. It's, you know, metal thing. here, everything is done actually like software. So, for example, what like standard generator in case of short circuit, inject positive sequence of short circuit current, negative sequence of zero sequence of short circuit current, all this kind of stuff. Standard generation, you can start it, then bring voltage to 10 kilovolts, then bring to 132. You can do black start, then you can provide load from one, provide load from other substation, then synchronize from with other, because it's fixed mechanically, For this inverter whereas which HVDC belong, initially PV plants and wind turbine, wind parks, which are also have these inverters. They were working in, and even nowadays they are working in so-called grid following mode. So that means they will wait until voltages. For example, this here you have point of connection of generator at 132 kV level of transmission network. And here is, for example, wind generation. And there is network, and it will come down. Nothing will happen until you bring voltage. Then you step energize transformer, then energize cable, and once the voltage is bring to the inverter of wind turbine will see voltage is there, 60 hertz, I don't know, low voltage maybe 400 volts or something, and will synchronize and start. Once it's synchronized, will start rotating and generating, pushing energy into the network. So that means we grid following. Whatever grid bring to you, you have to follow voltage, which is bring, and frequency. And passive just generate and that's it. For HVDC and now for battery storage system and for new, especially big projects, for inverter based, it is required to have grid forming.
This grid following mode will be in BSSE?
No. This will be done everything.
RTDS.
In RTDS you will have a model, but within these cubicles you are testing should be done there. So again, these cubicles some computers inside with software which is developed by manufacturer. They are using software.
Smaller prototype, right? The cubicles. Can you see it is smaller prototype?
Well, I don't know which kind of software I'm using, but they need to make program, and the cubicles has to behave as to develop these functions.
What we mean by the cubicle, is it the components that are being used or that are being tested?
I don't know, maybe component to component, maybe they need to improve cooling system, because there is cooling system in electronics, similar to data center electronics. There is some losses.
Yes.
But you need to develop this in software, because they need to develop there and demonstrate the system behavior like this. So I explain grid following. In grid forming, you want to have, for example, battery storage system. In case of blackout, something will happen. You want to be able to bring voltage to either 10 kilowatt to 132 kilowatt, and the system has to behave like a generator. Grid following cannot do this, but this need to follow all this. It's really challenging thing, I would say. So then you energize neighboring substation, then you connect load, so voltage reflectors will change. Your system has to cover this, not to disconnect to trip, and at some point you can synchronize with other device, other generator, commercial generator, which is developing its own network there, and then this is how you, in case of blackout, this is how you do restoration of your system.
So the main issue here is that, for example, if we disconnect or overload the system, the change in natural generators that we have will be by inertia. But in DC, the power electronics have to compensate for that.
Yeah.
So, for example, they need to do higher switching or lower switching. That's the main issue.
Yeah. Basically, they need to put to simulate inertia. It's called, there is terminology that is called artificial inertia. So you have to put, if you have inertia normal generation and something happen, then you will have change in frequency in power, which is delta P to delta T. It will take some time. Electronics devices, they can immediately ideas can immediately react within 2-3 millisecond time, which is quite fast. So you have to tune this to behave like this one, once you have small changes of frequency, for example, you will follow around 60 Hz because your number 60 Hz always goes around 60 Hz, ups and downs, Load increase, generator increase, loading, and they're chasing each other around 60. It's normal, but in case of fault, this change in frequency is high, and you have an inertia. So, for example, these devices are capable of tripping immediately and blocking. So I said, no, I don't want to be blocked. I want to withstand some time, to behave like this. So then they need to do programming. There is some curves. Then there is some, they said our system will behave like this. Okay, let's see. Then they will simulate this, all this. So there are reports in Accoms. But it's too complex to read all of this.
So this grid forming concept is a property of VSC converters or also LCC?
Oh, I don't know. For VSC, yes.
VSC, sure, because...
but for LCC, I was not involved in LCC, I could not say.
Because for newer projects, I think they are focused more on VSC, right?
Yeah, VSC. I think for VSC, for which... Yeah, I can't LCC, what LCC can do in that regards. No, LCC cannot do reactive injection. LCC is a bit different.
And what you mean by grid following is that like for example, the wind farm itself, or the wind energy will not operate unless it receives like voltage from the grid itself.
Yeah, until voltage is...
Then it will start to contribute.
Yeah, I understand. But for grid forming, so this is grid forming. Grid forming, you can start from zero, and you can, but you need to. But there are very few situations. I'm just thinking. For example, imagine there is also AC line connected between some. But imagine this AC line are not available. We're connected only through HVDC. So in case of blackout in west, you will be able to inject, let's say, power from central to west.
To the converter station there.
Yeah, to the converter station there. And now, if you have no grid forming, you cannot do much. You can just, you're supposed to wait this generator to connect, to bring voltage here, then you can connect to the network, then with grid forming, you will no need to wait with this generator. You can start forming here, so you can energize here, maybe provide some load for something, then this generator can synchronize with you, so you can go, so you're able to control, command. And it's, this is another thing on the project. It seems Chinese manufacturer never did this before. So they need to develop it, and well, this is another issue. Now the target is to.
So, what we mean by grid following is that it can stand on its own.
Yeah,
So it can start from zero. No need for any interaction with the system. But in grid following, what do we mean?
With grid following, you need to have behind. You see, I explained here. You see, if you want to make grid following for gas, like out here, you need to have energy from some place to push it through here and to provide power to loads here. So, for example, you will ideal situation will say, okay, guys, we have like out here, we need. You have to check whether your generators has capacity to increase power, and they will come back to say, okay, we can increase 2-3 gigawatt or 4, but step by step. Then you will energize, connect load, and this commercial generation will increase power generation and push it through this. So this is how we will do it through HVDC. Battery storage will be similar because you have a power battery, but at the moment it's maybe around 2 hours usual, but it will be increased. Again, you have power storage and you can do this grid forming. But for others, it's a bit difficult. You need to have something to create power to
AC accelerators. Batteries for, I think, DC, right?
Yeah, batteries are also DC.
Yes.
Yeah, batteries also there, and they have also same technology like for HVDC. From this DC part, they will, but not on this scale, like 2 gigawatts. It's batteries maybe a lot of batteries, each I'm guessing 75 megawatt, let's say, or something. So then they will connect it to the network and connect it to 80 kilowatts or something. Similar for wind turbines. Wind turbines has this windmill, on the pole, and you have everything is there. Actually, there is generation, and there is now latest generation wind turbine. They're generating various frequencies.
Because it's not uniform.
Yeah, and generate AC, and at the same this nacelle, it's called. You have from this AC, you will have conversion from DC
Back to
and again to AC, but 50 or 60 hertz.
Because it's not uniform and we cannot control it.
Yeah.
So it will output different frequencies.
Yes, and it is, it's usually grid following for now. Maybe it will change. So these things, these topics are generally live, in terms of developing and studying how the utility will deal with this. I personally was involved in some few projects actually, these renewables, where the project started and grid code was not ready for this project yet. They still didn't define these parameters for the study because it's brand new thing for example, for a utility, and they started studying. They're looking in other utilities what is their experience, what they so a lot of exchange of information. So they do sometimes this change of grid code ad hoc if they so identified some issues they're trying to incorporate in trying to tuning. And this process is ongoing generally. So it makes study and operating with the network more complex. Yeah, we'll see how. At the end of the day, I see this like mixture of renewables and conversion generation. A lot of theoretical things needs to be again studied.
So the main reason for this study is to observe the system and also to minimize the error in the system.
Actually, for each project, including this is a large scale, but for each project, even for common, typical, let's say, step-down substation from 132 to 33 kV level, which will supply, I don't know, industrial, oil and gas area, for example, or something, studies are done. And why are you doing these studies? You want to check if your equipment is like pre-selected, you want to check with load flow kit. There is really protection, coordination. Like you actually, during project execution, you want to make sure that you are not making any mistake, which could be very costly if you discover something in late stage of the project. Because when the project is about to be energized and you discover your rating of something is not good, or you will have issue, or you will have to decrease power or something, it will cost you a lot. Because you will go to contractor and say, okay, now urgently I need something else. If you do urgently, cost you 2-3 times maybe than usual. Because you need to energize. If you are late, for example, oil production will be late and someone will be angry, and it's so studies are there. This is during project execution, but also during maintenance period. It's good, if you have good model, you can operate your network. For example, you say, okay, now load is that much. This transformer is about to need to do maintenance for it. So what if I disconnect it? I have to disconnect it to do maintenance, to take oil samples, to do whatever is done there, needs to be done there. And you want, during this maintenance, you want your system to work normally. Then we will, in the software, disconnect this and run simulations and say, okay, when this is disconnected, what if fault happened here, there? Then if the study says you will disconnect faulty whatever cable transformer, but power will be still there, it will not be shut down, complete the system. Then you say, okay, now I'm good, and then you arrange with maintenance people, okay, next week you can go disconnect this, or study says, okay, system will shut down, so but will not shut down if you decrease load there, or you do some, So it's in that way. Software later could be used also for software one could be used for during maintenance period to do proper planning for power plant, but also the state level as well. Yes. So I don't know if I give you interesting thing, but so that's basically. I wanted to avoid that. Just provide slide with bullet points and. This study, it will be, even the situation which I found on the project when I joined the project, because I was not from the beginning, I was lost for some time, and a couple of people really took me some time to catch all the things where we are at the moment, because the kind of usual structure and this usual approach is not followed. Chinese contractors, they didn't do it before, and it's not done before actually. So this is why we need studies, and it is related. We're starting from desktop study, then we do real testing based on computers. And and even after installation, during commissioning, something may happen. So maybe behavior of the network which is not captured here.
But minimized.
But it's minimized. Even if it's happened, you say, okay, we done our best, what is available in the world, so we cannot always be perfect. So that's the.
So some of these tests are done in the planning phase, some are done after the manufacturing, right?
Yeah. Some of these are.
So like I said, as the PSSC, this is done before?
Yeah, no, these tests are not done. You cannot done this. You can just, what PSSC, when you're doing in this stage, they will just model roughly, it's
estimation.
Yeah, they will just, to simplify, they will just inject load, additional, for example, if it's 3 gigawatt, they will say, okay, how my system will behave if I'm taking it from west and pushing it to central. And then they will do it this way, and then they will run complete network simulations fault. There is, you can do it automatically, which will simulate fault on each bus bar. Fault results could be automatically some activities. Then and C shows it. Then we will do fault and 100 milliseconds. This bar is voltage is to 0, fault, three-phase fault in that case. Then fault is cleared by protection. That means after 100 milliseconds, protection will disconnect this bus bar with all neighboring. You simulate this case, and you see if the system will remain stable. Okay, and you see, and the software will tell you how the system will remain stable. So that means when you're sitting at home and you see your lights, blink. That means fault happened there, fault cleared, but you still have power. So they will do these simulations. If during these simulations they identify that the system will become unstable, for example, they will say, okay, how to make it stable? So they will say, maybe, okay, besides building this in order to accommodate this, energize this HVDC future, let's say in 2027, in this planning, they will, so that this will also, system will be unstable, but if we build one more line between this substation somewhere else in here, the system will be stable. So in some situations you will have contract for this HVDC, but in parallel Saudi Electricity will have another contract to build some cable line, which you initially says who need this. It's not, because there is already two within this substation. Why you need one more? Well, one more or additional investment may be required to keep your system stable in case of fault, bus bar or fault on HVDC. So this is why this kind of testing are done here. It's not.
So this is done before.
Yeah, this is done before. Here it is very detailed testing, so we want to have after initialization as much as exact as possible. So, but talking about all system studies here in PSSA, it's completely separate thing. A lot of processes is most common, but there's also interaction studies, a lot of things. From planning point of view, some basic studies are usually done, and the output from training is yes, could be done, but you need maybe do this or no need additional investment. For example, for the load flow, you have generally you heard n-1 requirement, or n-2 in some cases. So you also will simulate this. What is the line is strict of line? What if I'm doing maintenance of one line and one generator trips because of something? The system should remain stable. So this is, you go up to -1, in some cases -2, but you cannot usually do this around when -3 or so, because it will be too expensive. You will have a lot of generators which are just sitting there and waiting for fault, which is not, it's difficult to justify this investment. You have other issues.
Because I think if you lose 3 generators, I think you deserve the blackout. You didn't plan for it.
Well, you can have even some cases, usually when commercial generators are there, when you have peak load system is usually, it's not the rule, but in many cases I've seen they're very stable when it's heavy load. So I was usually saying, it's like you have a truck fully loaded, it's stable, you cannot do it. But if it's light load, even wind on the side can turn the truck, if it's stronger. So when the light load is the winter time, the system is more it's less stable, let's say, than usual. It's not. So that, I think that will be all about the studies and the project, and to give you a big picture about going in details, but we will take really a lot of things. Even I could not answer to all questions in details, because we have at the moment specialists for this PSSC. We're doing checking these studies in here, and we have specialists in PSK. Right now we have people in China. They traveled yesterday. They are there. They're doing one replica again of this test of some cubicles, not all. A replica. We got confirmation replica there is the same as, because some cubicles are already delivered on site. Shipped on the moment it's delivered. So let's say that we're trying to, since photography is not following strictly this, we're trying to find something in between, but the final ultimate target is to get the same thing at the end. Visualization. Okay, so if you have some questions related to this, or to start designing,
Thank you.
okay, good. Okay, I think that will be the idea. It is complex also. Okay, thank you guys.
Thank you so much.